Hello, my name is Maya. I'm a front-end engineer at Airbnb, and I'm here to talk about right-to-left language support and the infrastructure we've been building at Airbnb to get that working. So I'm going to start with a story. If you take Arabic in the US, you're probably going to use this textbook. There's really only one textbook for learning Arabic in the United States. It's Al-Kitab. And kind of hilarious about this, people have a lot of feelings about this book. In this book, we meet Maha, she lives in New York City. She studies English at NYU, and she's been described as a terminally pessimistic and culturally dispossessed teenager. Lovely. We also meet Khalid, who lives in Egypt. He's getting an MBA from Cairo University, very exciting. And he's a chronic misfit with a sidekick friend. Now, these two characters from Al-Kitab, the reason I'm introducing them to you is because, obviously, this is a love story. Now, these two teenagers, they live a bit far apart, so if, let's say, they wanted to take the next step in their relationship, Khalid might want to come visit Maha in New York City, fly over, but of course, they've just been exchanging some emails, talking a little bit, and hotels in New York, they're really expensive, they're like $300 a night. It would definitely be imposing on Maha to ask to stay with her, which is, of course, where we come into play. Now, what do you think happens when Khalid, today, on May 17th, goes to Google, types in Airbnb in the Egyptian website? Unfortunately, he gets an English language version of our site. And that's because supporting Arabic is hard. And so this is how our love story ends. They kind of grow farther apart, they stop exchanging emails, they move on to other relationships, and that's kind of it. It's kind of sad. So I believe in true love. So we're going to go on a journey today to see how we can solve Maha and Khalid's issue, get them together, and get them happily ever after. Today, to do that, we're going to answer some questions. The first, besides obviously this super compelling love story, is why support right-to-left languages at all to people in the world? Not very many. We're also going to talk about why it's so freaking difficult on the web today. And we'll discuss the tools that already exist that we can leverage for the situation. And finally, I'll go into detail about how we did all of this at Airbnb. So the short of it is I'm going to show you how to turn this screenshot into this. And this presentation is probably the only appropriate use of Keynote's flip animation. So enjoy the number of times I flip screenshots for you. Jumping right in, before we build all of this new infrastructure, it's really important to consider who we're building right-to-left language support for and why we want to support it at all. I am, of course, tempted to go back to the title slide, tell you it's the right thing to do, and walk off the stage and be done with it. But we have a little bit of time, so we'll delve into the details. So it's difficult to pinpoint an exact number of languages that are written right to left. Lots are written in multiple alphabets, but a huge number of people speak, read, and write these languages. Arabic alone is the 5th most spoken language in the world, with estimates from 300 million people up to 425 million people in the world speaking some variant of it. So shout out if you're one of those people here today. You couple that with languages like Hebrew, Persian, Urdu, and more, and you easily add another 250 million people who would benefit from a web that readily supports right-to-left languages. Now, since Arabic is one of the most popular of these languages, we have the most data on Arabic speakers, and specifically on that growing Arab digital generation in the Middle East. And I'll give you some numbers to support this. Internet penetration in the Middle East is actually higher than the global average of 51.4%, clocking in at near 60%. And in some countries, like the UAE and Qatar, over 90% of people are regularly on the internet. And these aren't just casual users, these aren't internet cafe users. 40% of the Arab digital generation is on their phones, on their computers, more than 5 hours a day. Now, even if you and your particular business doesn't have a lot of stuff going on in the Middle East. Obviously, people who speak these languages have spread out all across the world. There are immigrants everywhere, Europe, US, South America, everywhere. And so, in fact, 4 to 5% of all internet users speak Arabic. And get this, English speakers have grown about 600% since 2000 on the internet. Arabic speakers have grown over 7,000%. That's huge. And what's more, 60% of these people, they would pretty obviously prefer to have content in their own language. And so much so that when you look at statistical trends, Arabic speakers prefer blogging and kind of other content creation platforms, and you can see that they're trying to fill that gap. So how are we doing as a group? Turns out only about 1 to 3% of the world's top 10 million websites by traffic have any Arabic content at all. I really think that the people in this room are the ones who can move the statistic in a positive direction. But for a lot of our web apps, this has become non-trivial, which begs the question, why is this so hard? If we were just supporting basic Arabic text, like this greeting I might send my host on Airbnb introducing myself, we could simply write align our pages and be done with it. Easy. But of course, Airbnb, like a lot of other sites out there, has a ton of user-generated content, which creates a bidirectional text environment. While our curated text may be only shown in Arabic, things like names, reviews, listing titles, descriptions may still be in English or some other language, which again, creates that bidirectional text environment. And even if we didn't have this challenge, surprise, Arabic and Hebrew are bidirectional by default. Numbers are still read left to right. So even the most basic information, like my arrival date, telling it to my host, would still create that bidirectional text environment. And then you get into inputs. If you have to handle an input in any language, that opens up questions of directionality in the UI. Do you justify the input according to the content of the page? Do you decide on the fly based on the characters that are inputted? What about prefixes and suffixes? How do you handle numerical content, mixed content, straight text content? There's a ton of open questions about how to create the best user experience. And when you add a little bit of directional styling to the components, floating things, adding corners, adding padding, that too needs to be mirrored somehow to make sense. And finally, iconography and other images need to be taken into account. If text is flowing right to left, arrows, chevrons, and images likely need to be modified to point in that direction as well. And what about IDs, search icons, check marks, even universal icons like for accessibility? We were left with a ton of open questions as to which icons needed to be flipped, which needed to stay the same, and the result was that we'd actually have to have a little bit of both. So some way to automatically flip them and sometimes keep them in the same direction. So in summary, to have a truly comprehensive system for right-to-left language support, we just somehow cobbled together something that supports not only right-to-left directional content, but also bidirectional content, definitely in the same page, sometimes in the same sentence. We need to figure out how to allow users to input text in whatever language they want, and we need to allow for custom styles to be flipped. Things like padding, alignment, borders, etc. We need the same allowances for icons and any other imagery, and just in case, we need the ability to opt out of any of these automatic style flipping when possible. And so the big question becomes, we have about 600 product engineers at Airbnb. They're all writing their components in a certain way. How do we make all of these modifications with minimal disruption to their workflow and to the existing components in our codebase? And so the first thing we can do is analyze what's out there, what kind of tools are already available to us. The main tool at our disposal is the HTML dir attribute. This is not a new feature. This is kind of the opposite of a new feature. It was introduced to the HTML spec in 1999 and meant as a holistic solution to the challenge of supporting right-to-left languages. That means the browser support is bomb, but it also means, somewhat unfortunately, it was built for a very different web. So, if we were to time travel back in time a little bit, and look at a beautiful, brutalist Airbnb.com circa 1999 or so, we'd actually have enormous success just by setting that dir attribute on the top level DOM element. Enjoy that flip. This attribute's designed to automatically flip any tabular and inline block layouts. So in this simplified Airbnb design, the content is all right aligned, labels are on the correct side of their respective inputs, and tabular information like the calendar or even our grid of experiences all gets mirrored as expected. So our first step, and the first tool we ended up building, was to have some sort of wrapper to set this dir attribute at the top level of our pages. And talking a lot about all of this new context API, it also made sense to make that variable available to components anywhere in the tree. So one of my coworkers, Yaniv Zemet, conceived of and implemented this particular library. It's called React with Direction, and it follows that context provider and consumer pattern that we're all so familiar with. It ships with two main exports, the direction provider, which sets that dir attribute on a top-level node, and a with direction wrapper that consumes the value set by the provider and sets it to children as a prop. Now, obviously, we can see this evolving as render props become more of a thing, as the context API changes, but this is the current state of affairs. So in reality, if we wanted to create a very basic step incrementer component, we might have a little chevron that when we click, it would bump that number up appropriately according to the state. If we wrap it in a direction provider that sets the direction to RTL, things get flipped, but they look a little weird. What this is actually doing under the hood, of course, is just setting that dir attribute to RTL in the top level node, which flips the content because it's styled in an inline block manner, but our chevron's still kind of pointing in the wrong direction. So to solve this, we want to create a direction context aware icon. Let's call it icon chevron next. By default, it still returns that right-facing SVG, but if we wrap it in with direction, we get access to the direction as a prop, and we can return a left-facing icon in the appropriate context. And just dropping this in, this becomes pretty powerful. We can easily see how we can modify a ton of our components and adjust their behavior according to this top-level directional context. So we took a look at one of our most complex pages on the site, the listing page. Tons of content, tons of interactivity, and we wrapped everything in the direction provider just to see how many of these components would have to be adjusted accordingly. And unfortunately, it turned out to be quite a lot. Even the most basic features of this page, like the fact that the book it box is on the latter half of the page, don't get mirrored. There's a lot of weird padding issues. You can see the alert, that light bulb has some text overlaying on it. And a lot of these stem from the fact that in 2018, we're not really using inline block and tabular layouts anymore. We're using a whole lot of other fancy things to make our pages look really good. So we started investigating some automated style flipping options out there. And there's a lot. There's R2, there's CSS flip, RTL CSS, CSS-JS, there's even a Webpack plugin. But unfortunately for us, these all came with one major caveat. They all worked for CSS style sheets. This may have been good for us in 2014 when we were kind of a backbone Ruby on Rails, Sass workshop. But when we had been moving to React at that time and kind of rewriting a lot of our pages, we had asked ourselves, how do we style modular React components while minimizing side effects between them? And the answer for us, you can fight me about this later, was put our CSS in our JavaScript. So we're going to assume right now that everyone in the room agrees with me and thinks this is the right path forward and just move on. We can talk later. The paradigm of choice that we went with is Aphrodite. There's a lot of reasons for this. Again, we can talk later. But right now, we're going to focus on the right-to-left language support. Our components all sit on top of Aphrodite, and it offers us two opportunities to access those defined styles and do maybe some automated flipping magic. The first is at compile time. Basically, the component sends a set of preset styles to Aphrodite, much like you do class names and style definitions, and asks it for something to use. Aphrodite does some magic under the hood, whatever, gives us back an object that we can reference later and apply to our DOM nodes. We're going to call this the create method. And we have another moment where we have access to these styles as well, and that's at runtime. And this is basically, once we have that styles object, we want to apply them to a specific DOM node. So we pass in an array, we have some container styles, some container large styles. Aphrodite, again, does some magic, injects some styles into the page, and passes back a class name, which we can then apply to our DOM node. And this is what we refer to as the resolve. Now, these two steps combined give us not one, but two places where we have access to the styles. But with this structure, any changes we need to make to support automatic style flipping are either A, in our components, we have 10,000 of them, not a good idea, and B, in Aphrodite, which is a pretty popular open source library and maybe not the right place for what is at this point an experimental technology. So, fortunately, we'd already kind of thought about this and built in an abstraction layer called React with Styles. This may seem kind of weird to add not one but two packages between these things, but React with Styles defines the way our components are all written, and then the interface is the translator between a solution. And what this allows us to do is, with one line, swap between Aphrodite, JSS, even build for React Native, and somewhat hilariously, we can even turn it back into CSS style sheets. Now, the changes to the system here is that at create time, same thing happens. Component has these class name definitions, passes them to React with Styles. React with Styles doesn't really know anything about this, so it just defers to the interface. And in this case, the interface just talks to Aphrodite, passes stuff back up the tree. Main difference now, we can access that styled object as a prop. On the resolve side, again, if we're trying to pass in an array of various styles to put on a DOM node, React with Styles, kind of dumb, doesn't really know how to do anything, just asks the interface. Interface talks to Aphrodite, and we get some stuff passed back up the tree that we can now spread onto our DOM node. This is important because React with Styles isn't married to inline styles or class names in particular. It just gets back an object, and the DOM node just takes whatever's in there and puts it on it. This allows us to also have dynamically generated styles at runtime. So you may make a call to an API, you may do some animation, you want to calculate something at the render time. You pass in an object to React with Styles. React with Styles, again, defers to the interface. The interface is the translator for Aphrodite, so it knows that Aphrodite only deals with class names, and it doesn't have a class name for this object. So instead, passes it back up the tree as an inline style, and that gets spread onto our DOM node. This is the state of the world that we're dealing with, and what this actually allows us, which is pretty cool, is this interface layer. It's not part of Aphrodite, it doesn't change how we write our components, and it's a great place to do any automatic style flipping for a right-to-left context. So, before we move into our actual implementation, let's talk about the requirements. One, we wanted to handle all directional styles. So everything from text alignment, floats, padding, margins, transforms, all that kind of fancy stuff needs to be handled by our implementation. We wanted no changes. This is really big. No changes to how developers write components. So ideally, this should be invisible and should just work. We wanted to handle both the Aphrodite-generated class names and the inline style objects, just in case there was something that needed to be flipped there. And what's more is we wanted to have minimal performance impact. That's a lot of the reason we actually ended up choosing Aphrodite as our solution, and we wanted to maintain that strategy moving forward. So, attempt number one. You gotta love number one because you know there's gonna be a number two. So some important considerations that informed this first trial was that create happens at compile time. We talked about this before, but it doesn't have access to any sort of React context at this time. And resolve happens at runtime, But the state of affairs at this point was that it was defined once and being exported as a singleton. So it wasn't in the tree. It also had no access to React context. We don't have any access to directional context. This is very important for the solution because it means that whatever we write in left to right has to work in right to left at the same time. There's no switch that we can flip. But there were a few things we could also leverage in this system. We built this direction provider, so we can assume that all of our apps have that top-level dir attribute set. And, super cool, Aphrodite has a built-in plugin system to handle fancy custom style selectors. So our first strategy was to leverage Aphrodite's plugin system to create descendant selectors for default styles in a dir equals LTR context, so that's as written, and flip styles in a dir equals RTL context. This is a long sentence, so let's actually talk about what that means. Normally, we write our CSS-in-JS as a JavaScript object, something like this, to apply text color, to be red. Don't do that, it's awful. But this turns into some very basic CSS. We get a class name, it's hashed deterministically. The important tag is another thing, but this is the CSS that gets generated with very basic style definition. Aphrodite has built-in support for things like pseudo selectors, and it uses that plugin system. So something like this, you have the container class, you have a special key, anything that starts with a colon, and this actually gets transformed into a proper pseudo selector definition in our CSS. So our idea was to add 2 new custom selectors. We would have this underscore RTL one and this underscore LTR one. And the way we would transform this CSS is to have this descendant selector. So the styles that are being applied depend entirely on the context of the page and on that top-level dir attribute. Going back to our lovely system, we actually chose to ignore the create step at this point because we didn't have access to inline styles and we knew we'd have to flip those anyways. So we focused entirely on the resolve. In this first step, we have our array, we have a dynamic style, we have a static style. We ask React with styles. Again, pretty dumb, defers to the interface. And the interface is where the magic happens. Before, for those styles.container definitions, we would simply pass them unchanged to Aphrodite and go back up the tree with whatever it returned. Now, what we wanted to do is to transform them into our new RTL LTR style keys. And we do that with Kent Dodd's super cool RTL CSS-JS library. And then we'd enable our custom plugin in Aphrodite, and things should just work. So if we think about our resolve static styles function here, we actually dug a little bit into the meat of what that object looked like. It has that class name already and the definition right in place. So we could manipulate it. Add the LTR key, add the RTL key with the flip styles, do that flipping in place. That library is very fast. It's basically just like O of 1 transforms. Pass that to Aphrodite, and what goes back up the tree is the same thing we'd expect. We just get that class name, we spread it into our DOM node. But the difference is this is the CSS that gets injected into the page. For dynamic styles, we do something pretty similar. Defer to the interface. Before, the interface would pass it back up to the tree to the component. But now, we'd actually transform that style into an Aphrodite class name in place. We'd enable our custom plugin, and most importantly, we'd only do this for directional styles. Because again, this is probably going to be the most expensive part of this entire solution. So something like a left definition, we'd force it into a hashed class name using the Aphrodite library. We'd create those 2 keys, we'd flip the right to left one, and we'd simply call Aphrodite's resolve method. Aphrodite would pass stuff back up the tree, and we'd get a class name this time to spread onto our component. And again, the injected CSS would have those descendant selectors. And this was pretty cool. Something pretty fancy, like this cute little rolling switch that we have. That animation's done entirely in CSS, so we flipped it in the strategy, and it just worked. Pretty neat. But, attempt number 1, we had some failures. Descendant selectors do not offer context switching. I talked a lot about user-generated content. Reviews may be in English, descriptions may be in English, maybe in other languages. And at this point, any left to right content in a right to left page would have both sets of styles applied to it, which is bad. Descendant selectors coupled with shorthand and longhand would cause specificity issues. And funnily enough, the React 16 upgrade causes a lot of pain points in this respect because the server-client mismatches in our system started causing strange behavior, and that inline style transformation wasn't always the same on server and client. So we went back to the drawing board, took a look at our requirements, and made one major concession. We would allow changes, but they'd have to be very easily code moddable. And of course, we wanted to handle that context switching. We wanted to not introduce any specificity issues and not cause a server-client mismatch. So the new strategy became using contextual create and resolve methods based on our direction, again, leveraging that direction provider. So whereas before we had this compile time create, runtime resolve, we now have two methods for each of these scenarios. Instead of at compile time, we defer that create to the first render, which was actually a little bit beneficial because we'd be creating the styles only for what was actually rendered for the page, not for everything that was ever imported. And then at runtime, we changed the resolve method instead of being a global export to being a prop. So going back to our stack, the component would ask React with styles to deal with this class definition. React with styles would call its interface's right to left specific create method when it was in that context. Then the interface would simply flip those styles in place, pass that to Aphrodite, and we'd get that same style definition back up the tree that we could reference as a prop. On the resolve side, we would have, again, that same call, static styles and inline styles. Static styles have already been dealt with at create time, so we just have to deal with those objects. React with styles would call the RTL specific resolve method. The interface, again, knows that Aphrodite primarily deals with class names, so we don't have to do any conversion anymore because we know we're in a right to left context. So it flips them in place and passes that back as an inline style, which we can then spread onto our DOM node. And the only change that we needed to make to our components, and again, this is not very, but it's very possible to do with a code mod, is that resolve method that was previously imported from React with styles now is just a prop. And the final result was pretty freaking cool. We ended up having all of that styles that we saw the challenges with when we first flipped this listing page just work. And we haven't yet launched, but we hope to do so soon, and we've done a ton of testing, and the engineering is actually pretty much all in place. We're just waiting on translations. So we can now finish our love story and bring Khaled and Maha together. Links. Check out React with Direction on GitHub. It's open source. React with styles is also open source. It's a very interesting abstraction layer. If you're excited about CSS-in-JS, again, come fight me later. RTL CSS-JS is a great package. Kent Dodds is a great guy. And of course, please, please, please tweet at me any questions, any comments, any concerns, all that sort of stuff. I'm very happy to chat with you. Thanks.